Hello friends, welcome to this video on the topic Educational Data Analytics. Here I am Shomir Roy, Professor of Computer Science and Engineering at National Institute of Technical Teachers Training and Research, Kolkata. The entire topic of educational data analytics is covered in two videos. The present one is the first part. In this video, we will discuss certain interesting subtopics such as learning associations, classification, regression, and role of educational data analytics. Rest of the subtopics include behavioral detection, data synchronization, feature engineering, and feature generation and feature selection for behavior detection. And of course, some case studies. This will be discussed in the second video. After successful completion of these two videos, you will be able to 1. Explain the basic concepts and components of educational data analytics. 2. Initiate activities to apply techniques of educational data analytics in teaching learning. Let us start with learning associations. Quite often, large databases contain hidden knowledge which is very much useful in decision making. Such knowledge exists in the form of associations implicitly existing among the attributes. As an instance, let us consider a small database on a few students showing the three major subjects taken at higher secondary level and the stream they have chosen at graduation level. A careful scrutiny of the table reveals that students who had mathematics, physics and chemistry as their majors in standard 12 have chosen engineering at graduation level. Similarly, those who had economics and mathematics have chosen commerce, and those who had biology and chemistry have chosen the discipline of medicine. Therefore, it is logical to associate the set mathematics, physics, chemistry with engineering, economics, mathematics with commerce, and biology, chemistry with medicine. Symbolically, this can be represented with three association rules, namely association rule number 1, physics, mathematics, physics, chemistry to engineering, association rule number 2, economics, mathematics to commerce, association rule number 3, biology, chemistry to medicine. Hence, learning associations or association rule learning may be defined as a machine learning process of discovering useful and interesting relations among the attributes of a large database. Such relations are usually termed as association rules. In real life, association rules are probabilistic rather than deterministic. For instance, suppose student number 2 chooses commerce instead of engineering as his career path. Then the association rule mathematics, physics, chemistry to engineering would have a probability of 2 by 3 is equal to 0.67. It means 67% of the students who has taken mathematics, physics, chemistry in their standard 12 as his majors are likely to choose engineering at graduation level. Now we come to classification. Classification is a process of recognizing the category or class to which a given object belongs. A classic example of classification is handwritten character recognition. Every person has a unique handwriting style, and moreover, every time a person writes a character, it is written a little bit different from previous instances. Yet, a human being can recognize these handwritten characters instantly. We are able to do it because in our mind, each alphanumeric character corresponds to a class. Whenever we see a character, we make a judgment about to which character it resembles best and classify the input to that character only. Classification is done in computers with artificial neural networks, in short ANNs. In particular, multi-layer feed-forward neural nets. Here the inputs are presented in the form of m-dimensional vectors to the input layer consisting of m input units. These input patterns are to be classified into one of the n classes. So, the ANN have n number of output units in the output layer where each output unit corresponds to a class. The ANN must be trained to perform the classification. Supervised learning, that is learning in presence of a teacher, is relevant in this case. Let xm, ym be a pair of vectors indicating the input pattern xm is equal to x1, x2 up to xm should produce the output vector yn is equal to y1, y2 up to yn. This is called a training pair. A training set is a set of such training pairs. During the training phase, the ANN is fed with the input pattern of a training pair and the corresponding output vector is computed. The actual output is then compared with the target output and the error is calculated. This error is then used to make adjustments in the interconnection weights. In this way, the ANN is trained with each training pair of the entire training set. One such iteration is known as epoch of training. Learning by artificial neural network consists of many such epochs until the error is reduced to a tolerable limit. Once the training is over, the ANN is ready to classify unknown patterns. In case of handwritten character recognition, the ANN has to be trained with many sample characters before it is ready to classify the unknown handwritten character. Regression. Regression analysis is a statistical method to find the relation between variables as well as to predict the value of a variable, that is a dependent variable, with the help of other variables, namely the independent variable. Regression analysis can be divided into two broad categories, namely simple regression and multiple regression. Simple regression considers a quantitative, that is independent variable x to predict another quantitative and dependent variable y. The typical formula of a simple linear regression is given by the equation y is equal to beta naught plus beta 1 x plus epsilon, where x is the independent variable, y is the dependent variable, beta naught is the population y-intercept, beta 1 is the population slope, and epsilon is the random error. Multiple regression employs more than one quantitative or independent variables x1, x2, say up to xk to predict a quantitative and dependent variable y. Further, multiple regression can be either linear or non-linear. A linear multiple regression has a mathematical form y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus dot 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 up to beta k xk plus epsilon. There are various kinds of nonlinear regression such as polynomial, logistic, square root, reciprocal, exponential and so on. While linear regression is defined on continuous dependent variables, logistic regression is suitable to predict a categorical dependent variable. The mathematical formula for logistic regression analysis is given as log y by 1 minus y is equal to beta naught plus beta 1 x1 plus beta 2 x2 and so on up to beta k xk. The adjacent figure shows the form of logistic regression. Finally, we come to role of educational data analytics. Educational data analytics, in short EDA, is concerned about using the vast amount of educational data to better understand learning as well as the learning process. It is fast gaining importance in contemporary scenario of education. Educational data comes from several sources such as classroom, educational software, online courses, various assessment activities and so on so forth. The vast amount of educational data can be analyzed with the help of the state-of-art computational method to address important issues for the benefit of the stakeholder such as students, parents, teachers, administrators and policymakers. This figure depicts the role of educational data analytics in education today. Application of data analytics in educational system is an iterative cycle of hypothesis formation, testing and refinement. Knowledge obtained through educational data analytics enters into the loop towards guiding, facilitating and enhancing learning as a whole. Educational systems are designed, planned, built and maintained by educators and educational designers. These systems are used by the students for the purpose of learning. As a result, new data are produced about the courses, students, interactions, usages and so on. These data, when tested with appropriate data analytics tools and techniques, helps to discover new knowledge. The discovered knowledge can be used by educational designers, teachers as well as the end users, that is the learners. Educational data analytics has grown significantly recently. Its role in education is expected to go further in future. Advances in ICT and powerful computational techniques such as machine learning and deep learning have created a favorable context for greater participation of data analysis research by scientists, academicians and stakeholders. Friends, we have come to the end of the first part of the 2 videos on the topic educational data analytics. Rest of the subtopics will be discussed in the next video. I hope you have enjoyed the session and found it useful for your purpose. For further details, please see the e-contents of this lesson. So thank you very much and see you again in the next video.